Hey everybody, my name is Lee Pierce and I'm going to go over some EOC review. Now, if you're in my class, now this is spring of 2024, if you're actually in my class, I need you to grab a sheet of paper, go ahead and label it whatever the title of the Google form that you're currently working on. Label it right at the top. This is what I'll be putting in skyward as your grade, not just hitting submit on this, all right? You gotta show me your work, and some of it doesn't require work, and we'll talk about that as we go. All right, so you are working on this stuff while I'm out of town, and I hope you enjoy the videos. I hope they help as we work on this 1 through 10, proving triangles congruent. This is our EOC practice 1 through 10, proving triangles congruent using the side, side angle, and angle, side theorems, and then just generally talking about congruent triangles. All right, so number one, the very first one, match the corresponding sides of the two congruent triangles. The trick to this is paying attention to where the little tick marks are. So we've got a little tick mark here on FD and we've got one here on AC. So those sides are corresponding. So AC and FD are going to correspond, or DF. DF is the same as FD. AB has 2 tick marks and ED has 2 tick marks, or DE. So AB is going to correspond to DE. And of course, the one that's not marked, FE, corresponds to CB. So there we go, in order from top to bottom. All right, give 2 examples of pairs of sides that could be used to show that the triangles are congruent using angle, side. Now, the tricky thing about angle, side is the side does not need to be between the angles. Just like the S is not between the A's, the side that we're looking for is not the one that's between the angles. So we do not want to talk about ED and AC. That would be angle, side, angle. But this is angle, side. So we're going to use either of the other 2 sides. That's why it's going to give us 2 different answers, okay? So AB could be congruent to FD. That would prove it. Or BC could be congruent to EF. That would prove it as well. So we're going to have to scroll up here. So AB and DF, that's correct. And AC and DE would be congruent. There we go. Those are the 2 for that one. All right. In the figure shown, what additional information is needed to show that the triangles are congruent by side. So you have to pay attention to which theorem we're using. This time it's side. And pay attention to what's given. Watch what's given here. We know that AC is congruent to DF. And we know that DE is congruent to AB. So we only need one more side, and you can write it. This is a fill-in. Oh no, it's not actually. It's a multiple choice. BC or CB, BC, or it might say CB, needs to be congruent to FE or EF. Remember, that's the same side. All right. So let's see which one we got. CB and FE. It would be this second answer right here. Side BC is congruent to side EF. All right, good job on that one. I hope you understood that very well. Remember that we're reviewing for this end of course test, which is taking place here in about 2 more months. We're going to be doing a lot of miscellaneous reviews, but again, right now we're working on these congruent triangles, ways to prove that they're congruent, and then if we know that they're already congruent, what sort of properties do they have? All right, so find the value of x in the diagram. Here's where the algebra comes in. This is why you take Algebra 1 before you take geometry, because you have to end up solving for x. That's really the core of Algebra 1, solving for x, figuring out what's going on there. So let's do this one, find the value of x If we know that the triangles are congruent, which we do, then we know that their corresponding parts are congruent, because corresponding parts are congruent, triangles are congruent. Therefore, we know that that is equal to, that's the measure of side AB. This is the measure of side DE. We know that because the sides are congruent, their measures are equal, so we just set those two values equal to each other. Of course, then we have to solve it using our algebra skills, which should be pretty finely tuned at this point, and it's really good prep for Algebra 2 next year, all right? So 2x plus 3 equals 6x minus 9. We're going to subtract 2x from both sides. That's going to give us 4x minus 9 on the right and a 3 on the left. We're going to add our 9 to both sides. That's going to give us a 12. And then we're going to divide by 4. X equals 3, and we are done and moving on, all right? Remember, x equals 3, but x, if they were to ask us this, x is not the length of side AB. To get that, we would have to plug the 3 in right here. 3 times 2 is 6. 6 plus 3 is 9. All right, so that should be B. I hope it is. Let me make sure that I marked the right answer when I created this. Yes, sure did. All right, which is not a valid theorem to show that two triangles are congruent. Everybody knows this because it makes a bad word. However, for the purposes of course, being civil and creating a test, it's reversed. So, this one is that word I was talking about, reversed. Side-side angle is not a theorem which proves triangle congruence. All right, so moving on here. Which theorem can be used to show that the two triangles shown are congruent? So let's see. They are, first of all, there is a strong clue here because these are right triangles. That means we're probably not dealing with just regular sides and just regular angles. We're probably dealing with hypotenuse. I think that's plural of hypotenuse. Hypotenuse. So we know that this, remember the legs are the sides on each side of the right angle. So we've got this 3, we've got this 3, we've got this. So we're given the 3, that's the short leg, and we're given the 5, that's the hypotenuse. The hypotenuse is across from the right angle. So we know that one of the legs and the hypotenuse are congruent. Therefore, the right triangles are congruent because the hypotenuse and leg are congruent. We would go with B on this one. All right. In the figure shown, which two pieces of additional information are needed to show that triangle ABC is congruent to triangle DEF? Remember, we're looking for side, angle, side. So clearly we need two sides that are congruent and the angle between them, okay? So we need the two sides are congruent and we need the angle between them congruent. So let's take a look. We're only given one angle that's congruent to itself. So it's asking, what would we need to prove that the sides are also congruent? So we would need that to be congruent to that, and that to be congruent to that. So let's find those answers on here. So AC and DF, okay? So you have answer B right here, which is correct. And BC, be careful, it might be called CB, same thing, BC and EF, BC and EF. So there we go, P and S, that's it. All right, and I realize even if you have created this form, you're still gonna turn this in. A lot of this work didn't require any work, all right? Except for maybe the algebra. You're gonna wanna work the algebra problem on here, the one that we did 1 or 2 problems ago. So you may be turning in your work, you may not have a lot of work on it. I understand that. I'm going to take that into consideration. But I do need this in the tray so that I can give you credit in Skype. All right? Okay, let's keep going. I think we're almost to the end here. I think we are. How's the scrolling look? It's looking good. If we know that two triangles are congruent, what angles correspond to what angles? Remember, the name of the triangle is named by the vertices. It's named by the angles on the corners. So, and the order matters. L is going to correspond to X. M is going to correspond to Y. N is going to correspond to Z. So which one corresponds to M? That would be angle Y. There we go, right there. The middle one and the middle one. All right. In the figure shown, what additional information is needed to show that they're congruent by angle, side, angle? So we've got this angle, we've got a side. Remember, position of these letters is important. The side here is between the two angles. So whatever side is congruent to itself, to the other corresponding side, the angles have to be on each side of it. So here's one of the angles, here's one of the angles, here's the side that is congruent, here's the side that is congruent. So we can't go over here because that angle right there, angle A and angle D, are not on the other side of C. Our side needs to be between the two angles, all right? So we're going to go with C and F need to be congruent to each other. So C and F, we're going to go with A on that one. And we should be coming to the end here. Let's see, this is the last one, it looks like, on this particular Google form. And then you'll pick up, of course, on the next one. This one didn't take any more than about 10 minutes or so, right? Okay, it is known that these two triangles are congruent. Which of the following is not necessarily true, all right? If it's known that the triangles are congruent, which statement is not true? AB is congruent to DF. AB and DF. Those seem to be corresponding parts. So we're going to call those congruent. They go from the single arc to the corner that isn't marked, single arc to the corner that isn't marked. Those correspond. So it's definitely not M. AC and EF. AC, that goes from the single arc to the double arc. And EF, that goes from the double arc to the unmarked. That, we cannot say that those two sides are congruent. They do not correspond. They're not corresponding parts. So corresponding parts of congruent triangles are congruent. They might be congruent. Keep that in mind. They might be congruent, but we can't say that they are because they're not corresponding parts. Okay, that is the end of this one. Hope you enjoyed. Hopefully this stuff is making sense to you and going pretty easily. And we'll go on to the next one in just a few minutes.